Here is a first partial equilibrium model, and so this model is very simple. So why is such a simplicity? This is because, in fact, of course, this is the first model that you are going to work on, and so I don't want to start with something difficult. And the second reason is that I want to focus on the structure of the programming, because in all models that we are going to present during this curriculum, either partial equilibrium or general equilibrium models, the structure is exactly the same. So during the two curricula that you are going to follow during this year, you will work on two types of economic models. The first type of economic models is partial equilibrium model. So it means that it's relatively simple as compared to general equilibrium models, in the sense that we do not take into account all markets and all interdependencies existing in economic activity. So for example, if we study the rice sector, we do not consider what's happening on the labor market or the land market. So we uniquely study what's happening on the rice sector. Okay, and so we neglect a certain number of interdependencies in the economy. But the general equilibrium model, so we do not keep these assumptions, and we take into account all markets and all interdependencies. So for example, if we study the rice sector, we of course we study how what's happening on the rice sector affects the rest of the economy, and in particular the labor market, the land market, and so it modifies the equilibrium on these markets. And when equilibrium on labor market and land markets are modified, we also study the feedback effect on the rice market. So everything is taken into account in a general equilibrium model. So let us focus now on partial equilibrium models. So what we study, the object of the study is a sector. It may be two sectors with an economic relationship, and these two sectors may be in one country, or maybe we can consider to study one sector or two sectors all over the world. So the question is that it's not a matter of size. It's a matter of economic assumptions. And these assumptions imply that a certain number of markets and interdependence are neglected. In particular, we consider that consumers' income is constant, prices of productive factors are constant, and so on. So let us consider the simplest design of a partial equilibrium model. So this is one sector in one country, and I take the example of rice in Senegal. So this is our object of study. So if we consider the plane consisting of quantity on the horizontal axis, and the units are tons of rice, and the vertical axis, which is the price of a ton of rice, and we can consider that the monetary unit is franc CFA or whatever, US dollar or euros, but I consider here franc CFA. So if you ask yourself what is the factors determining the production of rice, you may think, and I think it's right, you may think that the productions of rice depends on its price, of course, but also on price of many inputs, and so it depends on the price of land, the price of machines, the price of fertilizers, and so on. So what we suppose in partial equilibrium is that the prices of these inputs are constant. Okay, so this is the assumptions characterizing partial equilibrium model. And so we can focus on the relationship between supply and price. And here I'm going to consider that supply increases with price, and this reflects increasing marginal costs. So let us consider now demand. We are still studying the sector of rice in Senegal. So if you ask yourself what are the factors determining the demand of rice, well, of course it depends on the price of rice, but it depends also on consumers' income and on the prices of all goods, and in particular the prices of other cereals that can be substitutes of rice. So what we suppose in partial equilibrium, and this is the key assumption of partial equilibrium models, we suppose that incomes and other prices are constant, and so we can focus on the relationship between the demand of rice and its price. Here I assume that demand decreases with price, which reflects decreasing marginal utility. So let us now see what are the relationship between Senegal and the rest of the world in the sector of rice. So what we suppose is that Senegal imports rice from the rest of the world. So what is the reason of this status of importing? Well, in fact, if we consider the world price of rice, which we call PE, and it is a world price of rice with inclusion of the cost of insurance and freight. So this price is under the autarky price, which is the price resulting from the intersections of local demand and local supply. So the reason behind that is the fact that maybe demand is very strong in Senegal, or maybe supply is uncompetitive. But this is a fact. PE is under the autarky price, and under free trade, Senegal imports rice from the rest of the world. What we suppose is that rice from Senegal and rice from the rest of the world are identical goods. These are exactly the same goods, and so it means that the substitution is perfect in consumption. That is to say, local consumers substitute rice from the rest of the world perfectly to local rice, and the rice which is produced locally is exactly the same as the rice imported from the rest of the world. And so the consequence of that is that there is a unique price of rice in Senegal, because we have a unique good. So another assumption would be to consider that rice from Senegal is differentiated as compared to rice from the rest of the world. We would have two goods and two prices, but here this is not the case, and we have a unique price of rice, and we'll see soon how to change this assumption. So Senegal applies an import duty on the importation of rice from the rest of the world, and even under this import duty, Senegal imports rice. Okay, so this import duty is defined in percentage, so this is an ad valorem import duty, and so the local price of rice is P, which is equal to PE, the world price, multiplied by 1 plus T, which is the ad valorem import duty. So the assumptions that we make is that whatever the quantity of rice imported is, the world price is constant. That is to say, the world supply of rice is infinitely elastic. So it means that whatever the imports are, the world price will remain the same. Okay, because Senegal is too small to change the world price of rice. We will see soon how to change this assumption. So if we look at the consequences of the applications of this import duty, first we can say that local price is augmented. Second, we can say that supply is augmented from x to x prime. And finally, we can say that consumption is reduced from D to D prime. And so this is because local price is increased, and so consumption is decreased. So let us remind the basics of partial equilibrium models. So we designed a model adapted to a specific sector, or maybe 2 or 3 sectors related by a specific economic interconnection. And maybe this is worldwide or specific to a country. But the most important point is that we do not take into account the equilibrium on all markets, and so we think everything else being constant. Okay, so that's the very basics of partial equilibrium models. And so in particular we suppose that there are other prices which are constant. Maybe it's prices of productive factors or prices of substitutes, complements, but there are other prices that we suppose are constant. And the same for consumers' income. We suppose that consumers' income is constant. So let us try now to write the mathematical model. So we are going to specify a few equations, but we need first some symbols, some marks, some notation. So we call XS the supply of rice in Senegal, XD the demand of rice in Senegal, P is the local price of rice in Senegal, PE is the world price of rice, MD is the import demand of rice by Senegal. So it means that it is the quantity of rice that Senegal is willing to import. And MS is the import supply by the rest of the world, which means this is what the world is willing to export to Senegal. So let us write right now the model. So the model consists in 6 equations. So the first equation is a supply function. It is P is equal to AXS plus B. So it's relations between the local price and the supply, the local supply. And the functional form is a linear relation. You remember the graph. The second relations is the demand functions, so it is P is equal to minus C multiplied by XD plus D, and so it's a linear relations between P, the local price, and the local demand XD. The third equations is the definitions of import demand. So it's excess demand, so it is MD is equal to XD minus XS, the demand minus supply. The fourth equations is what we call the small country assumptions, which means that Senegal is too small to affect the world market, so it means that the world price of rice is constant, whatever the quantity of imports demanded by Senegal is. So it's PE is equal to PE0, PE being a variable, but PE0 being a parameter. So we will call it, in fact, an exogenous variable. So it means that it cannot vary within the model. It is the modeler that decides exogenously to the model to change this value of PE0. The fifth equation is MD is equal to MS, so its import demand is equal to import supply. The sixth equation is P is equal to PE multiplied by 1 plus T, so it is the relation between local price and world price, and the gap between these two prices consists in the ad valorem duty imposed by the government of Senegal. Of course, A, B, C, and D are positive constants. So we've got a partial equilibrium model with 6 equations. So we have to figure out the number of endogenous variables, that is to say variables which are determined by the model. I'm not talking about exogenous variables which are of which the value is selected by the modeler. So the number of endogenous variables, so XS, supply of rice in Senegal, XD, demand of rice in Senegal, P, local price of rice in Senegal, PE, the world price of rice, MD, the import demand of Senegal, MS, the import supply by the rest of the world. So we've got 1, 2, 3, 4, 5, 6 endogenous variables. So it's okay because we've got 6 equations, 6 endogenous variables. The system is neither overdetermined nor underdetermined, so it's a square system, and we can find a feasible solution. So I would like to explain one important point. So we've got some flexibility here because we can reduce the number of equations and the number of variables. We could also augment the number of equations and the number of variables. And in fact, we would have exactly the same model. I'm trying to explain my point. So, for example, we can remove equation PE is equal to PE0 and replace the endogenous variable PE by the parameter PE0 everywhere. So it would mean that we've got a system of 5 equations and 5 unknowns, 5 endogenous variables. So it means that we would have exactly the same model. And in particular, we would have the assumption of a small country with a constant world price. So the number of equations and the number of endogenous variables is flexible. Another illustrations is M. It's possible to keep only M in place of MD and MS and remove equation 5, which is MD is equal to MS. We would have so a system of 4 equations and 4 unknowns, 4 endogenous variables. So you see that we would have a very simple model with only 5 equations and 5 endogenous variables and nothing new. It would be exactly the same model. So it's here we can keep 6 equations and 6 endogenous variables because the number of equations is very, very small, so it's not a problem. I think it's important to keep in mind that if you want to change a model, if you want to add new variables, new assumptions, you have to augment the number of variables, endogenous variables, but you have also to augment in a similar way the number of equations. Now we can do an exercise which is quite interesting. It's not mandatory, but I think it's worth trying to do this exercise. Why? Because first, it will be in fact necessary to have this kind of thing when we will do MCP programming. And second, because it helps us to understand the model. And third, it will be very helpful if we want to add new equations and new variables. So what is this exercise? It's simply that we can match each equations to a variable. Putting differently, we can in fact allocate each equations to the determinations of a specific variable. So here we have 6 equations and 6 endogenous variables. So I can allocate each equations to the determinations of one variable. So for example, equation 1, of course, it determines the supply, xs, because this is the supply function. Second, equation 2, this is the demand function, so it is determinations of xd. Equation 3, this is the definition of import demand, because it's excess demand, local demand minus local supply. So MD is determined by equation 3. Equation 4, well, it determines the world price, because it says that the world price is constant at a level which is PE0. Equation 5, in fact, you have MD is equal to MS. MD is determined in another equation, so it determines MS. And equation 6, well, you've got P, which is equal to the world price multiplied by 1 plus the ad valorem duty, so it determines the local price P. We can have a slightly different interpretations, because if you look at equation 5, it says MD is equal to MS, so its demand is equal to supply. Okay? When you have this type of equation, we can say that it is matched to the determinations of a price. And here, of course, as it is import demand and import supply, it can be, in fact, the determinations of the world price. Okay? But of course, the world price is determined by equation 4. So different interpretations would be, well, equation 5, MD is equal to MS, determines PE, and equation 4, PE is equal to PE0, determines MS. Okay, so this is possible. I accept the first interpretation here, and I think that equation 4 determines PE and equation 5 determines MS. But what you have to keep in mind is the fact that an equation supply is equal to demand may be matched to a price. So it's very interesting, because in fact you don't have the variable which is determined by these equations in the equation, and even if you have that, you have these equations that determines the price. Okay, so right now we are going to program the first model. So this is the model that we have just exposed, and I would like to start with an explanation of the structure of a program. In a GAMS file, there is a specific order of instruction. But of course, you have to work first on the model. So for example, the 6 equations that we have just designed and the identifications of the 6 variables endogenously explained by the model. You have to start systematically with this stage, because it's the most important stage of in the design of a model. Then you see, when you write a model, that you must define some sets, define some parameters, that you have to enter some data, and you have also to conduct what we call the calibrations, and of course you have to initialize the model. So in a GAMS file, this is the first stage, the first instructions that have to be written. But you have to, in fact, make this stage when you, on a sheet of paper, for example, when you have first designed the model. And then you have the definitions of the model. So it's a very simple instruction. Once you have written all the equation, you have to apply a shock and you have to display the results. So right now let us present the structure of a program. So in a GAMS file, we start with a series of instructions which consists in the definition of sets, definitions of parameters, the data entry, and the calibration. Okay? Why? Because in fact we are going to use the sets, to use the parameters after that, and of course GAMS would not understand if we use a parameter that is not already defined or declared. We cannot use a set if we do not declare this set before. So we have, in the GAMS file, we have to start with this. Then in the GAMS file, the second phase is to make the declarations of the variables, the initializations, the declarations of equations, and the definitions of equation. Then the third stage, you will see that we will have to define the model. We will have to make a solve without a shock. You will understand later on the implications of that and why we do that. Then we define the shock, then we make a solve, then we, in fact, we display results coming from the model and the shock. So this is the order that is in fact mandatory when you write a program under GAMS. But you, of course, I think when you design a new model, please start with the model, that is to say the second phase. Okay? So in fact it's very useful to start with the writing of the equation and the identifications of the variable, that is to say, in fact, the second phase. And when you write the model, you realize that you need some sets, you need some parameters, so you, in fact, understand what is the information that is needed at the beginning of the program. So when you have finished phase 2, you can work on phase 1, the beginning of the program, and then after that you can finish with phase 3, which is the definition of the model and the solve. So you are going to see at the end of the video an illustrations of what I'm talking about, because I will present the GAMS file that is the model that I have programmed under GAMS. And so all the different phases of this program. The key rule, once again, is to start with the model. Okay, that is to say, when you write a new model, you start with the writing of the equations and the identifications of the variables. So concerning this phase, in fact, we have a series of instructions, then a series of operations, and then I will present here the GAMS program. So what you have to write under GAMS to, in fact, complete this second phase. So these instructions, so in this second phase, is to concern first the variables. Okay, so you have to declare the variables. So you use, in fact, the instruction variables. This is very simple. And then you have the name of the variable, and then a text explaining what this variable is. So it's not mandatory to write this text, but I recommend to write it because it will help you to understand what you have in this variable. Then here you have the instruction variables. So it means that GAMS will understand that P is a variable, and you have added a text which explains what is P. It's the local price. Then XS, another variables, and you have the small text that explains what is XS. The second part of phase 2 concerns equations. So first you have to declare the equation. Okay, so you have to use the instruction equation, which explain to GAMS that you will have a certain number of equations, and so the beginning of the instructions after equations, you have the name of the equation. So here EQ underscore XS is the name of an equation, and you have again a small text, a short text, which explains what this equation consists in. Okay, so you can do it. You have to do it for each equation, and then you have the definitions of equation, of course, because in fact until here you have only the name of the equation. So GAMS has to understand what this equation is. And so you reuse the name of the equation, which is already declared, and you follow the name of the equations by a double dot. Okay, and so GAMS will understand that now you are going to define what this equation consists in. So this equation is P is equal to A plus B multiplied by XS. Two remarks at this stage which are really important. First, you do not use in an equation the sign equal to. You use equal, equal, which means must be equal to. So it means that P, the left side, must be equal to the right side, A plus B XS. And second remark, you have to finish the instruction with a semicolon. So let's suppose that we have declared the equation, that is to say we have declared the name of the equation. So now we can write the model. So first equations, it is P must be equal to A plus B XS. So this is the supply, local supply. Second equations, P is equal to C minus D XD, which is the local demand. Third equations, this is relations between local price and world price. So the gap consists in the ad valorem tariff. Fourth equations, we have the small country assumption, which means that the world price remains at a constant level PE0. Fifth equations, which is the definition of the demand for imports, which is the excess of local demand over local supply. And then the sixth equations, which is an equalization between supply for imports and demand for imports. MS is equal to MD. So once you have written this model, you can first identify endogenous variables. They are P, XS, XD, PE, MD, and MS. Then you can identify exogenous variables. So these exogenous variables, so these are variables. They can change, but they change thanks to decisions of the modeler. So for example, you have T, which is not explained by the model, but which can change exogenously to the model. That is, it is decided by the modeler. And then you have PE0, which is a parameter. You can have a change in the world price of rice, and you can see how it affects the equilibrium in this sector in Senegal. And then you have an identifications of parameters. They are here A, B, C, and D. So we can give a new illustrations of what I have just explained. Once you have written the equation EQ underscore XS double dot, so P is equal to A plus B XS, so this is the supply function. You can deduce from this equation that you need before that to declare a parameter A, and then you have also to declare another parameter which is B. So concerning the variables, so this stage requires declarations and an initialization. I'm trying to explain this point. So here you've got 6 variables, endogenous variables, which are P, PE, XD, XS, MD, and MS. These are the variables, and they are declared with the instructions variables. Very simple. Do not forget that it has to finish with a semicolon. Before that, you have to declare some parameters that I'm going to call P0, XD0, XS0, PE0, MD0, MS0. That is to say, the name of the variables followed by 0. And of course, every time you can add a text in order to understand what you are talking about. And once you have done that, and once you have given a value to these parameters, to P0, XD0, XS0, PE0, and so on, you can initialize the variables. So you type P.L is equal to P0, semicolon. So it means that the current value of the variable P is equal to the parameter P0, and you have given a value to P0. So it means that you have given an initial value to the variable P. Same thing for PE, XD, XS, MD, and MS. So you need to give an initial value to these variables. So right now we can think about the beginning of the program. Once we have defined the equations of the model, the variables of the models, and we have conducted an initializations of the values of the variables. So right now we can work with, of course, the parameters declarations and the data entry. So these data that we need, they concern local demand, local supply, world price, custom duty, and slopes of supply and demand functions. Okay, you will understand why they are not all the parameters in a few minutes. So you have to search on internet, on statistical handbooks. You have to collect some information about the sector of Senegal, of rice in Senegal, in 2016 or 2017 or maybe 2018. So this information, for example, concerns local consumption of rice, local productions of rice, the world price of rice, the custom duty applied by Senegal on its imports, and the slopes of supply and demand functions. So it's very heterogeneous informations, because in fact local demand and local supply and world price, you can have a look at different websites concerning the rice sector in Africa. Concerning custom duty, you have different databases that give you the informations on custom duty on each product in each country. So for example, you've got the International Trade Center website, and slopes of supply and demand functions. So it measures in fact the sensitiveness of supply and demand to prices. So you must have a look at the literature on econometric estimations of elasticities, and of course you have to make very rapid mathematical transformations in order from this elasticity to understand what is the value of these slopes, because the slopes of these demand and supply functions must reflect local elasticities of supply and demand to prices. Once you have done that, you can proceed to the calibrations of the model. So what is a calibration? Calibrations, it's something which in fact is maybe the most difficult part of the model. I can use the comparison of with mechanics. Of course, when you do some mechanics, when you, for example, design and build an engine, you have to be sure that every piece get into other pieces. Okay, so it means that here you have to be sure that you give value to everything which is used in the model, such that each equation is consistent and the entire model is consistent. So of course you have to calculate values for remaining parameters which do not have values until now, But you have to be sure also at the same time that each equation of the model is satisfied. That is to say, the left side of each equation is equal to the right side of the same equation. The difference is nil, 0. That is to say, there is no infeasibility. So infeasibility here is defined as the difference between left side and right side of each equation. Okay, so you have to be sure that initial infeasibility is 0. Okay, how do we do that here? Once you have given a value to local demand of rice, local supply, world price, custom duty and slopes of supply and demand functions, what you can type in the GAMS file is calibration. So this is just to explain what you are doing here in the program. So the calibrations, you have 5 instructions. Given what you have in fact typed before, md0 is equal to xd0 and x minus xs0. It is simply because before you have given a value to xd0, local demand, xs0, local supply. So if you take the difference, you will have the demand for imports, initial demand for imports, md0. Okay, and so it means that once you have typed this instruction, and if you give to each variable an initial value which is md0, xd0 and xs0, these equations will be satisfied. Second instruction, this is ms0 is equal to md0. This is another equation of the model. So you just gave a value to md0, so you can give a value to ms0. Okay, this is in fact logical, quite consistent. You remember that before that you gave a value to PE0, the initial world price, but also T, which is the ad valorem duty. So you can give a value to P0 because in the model you have an equation which is P is equal to PE multiplied by 1 plus T. So you can here type P0 is equal to PE0 multiplied by 1 plus T. And if you give the value P0 and PE0 to the variables P and PE, you will be sure that this equation is satisfied. The left-hand side is equal to the right-hand side. Then you have the demand and supply function. So, in fact, you know you already gave value to P0, xd0, and d, which is the slope of the demand function. So you can use all this information to give value to C. You can write C is equal to P0 plus D multiplied by xd0. So with typing this, you are sure that you give value to C, and also that in fact the equation will be initially satisfied, the equation consisting in the demand function for rice. And then you make the same thing for A, and you have in fact a new parameter which has a value, and you have also this equation of supply functions which is satisfied. So you are sure at the end of the calibration that every parameter has a value, and you are sure also that every equation is satisfied. There is one remark I want to make, but maybe you understood already this point, the fact that you have a specific order in the calibration, because for example here you give value to P0, then you give value to C. You cannot do, in fact, you cannot start with C, then P0. Why? Because in C you need to have a value for P0. Okay, so you must start with P0, then C. If you start with C, okay, then once you will give a new value to P0, in fact, C will be no more equal to P plus dxd. Okay, so this equation will no more be satisfied. So be very careful with the order of the calibration. because it has to be consistent in order to be sure that at the end of the calibration, every equation is satisfied. So now let's proceed with the end of the program. First, we have to deal with the definitions of the model, because of course we have declare and define the equation, but we didn't define the model itself. So in fact we have to explain what are the which are the equations which are included in the model. And so this is done with the instruction model, followed by a space, then the name of the model that the modeler chooses. So here I chose tariff. Then between two slash, you have to type the name of all the equations separated by a comma, or if all the equations that are declared and defined in the present file, if they all belong to the model, you can simply just type all, and finally you have a semicolon. Then what we do is that we make a solve, okay? And of course you noticed that there is nothing between the definitions of the model and this first solve. So in fact we do a first solve just to check that initial infeasibility is 0 or close to 0. And so it means that just after the instruction model, we type an instruction which is solve tariff. And in fact, we use CNS because it's a solver which is adapted to square system. Again, we finish these instructions with a semicolon. And then we implement a shock. So here, the initial tariff is 0, and I change it for 20%. So it means that for a tariff of 0, when the variables are initialized on the initial value of each variable, we've got an infeasibility which is 0. But right now we should have something different, because we have one parameter which has changed from 0 to 0.2. This is the import tariff, so 0% to 20%. So we type t is equal to 0.2, and then we ask for a new solve. And of course we should have an initial infeasibility which is different from 0, and we will have the solver that will find a new solution for the endogenous variable. And finally we have a display of results, which is simply excess display of excess point L. .L. So .L means that it is the current value of this variable. Of course, you can ask GAMS to calculate some parameters like the rate of increase in one variable, but you have, of course, to make explicit statement of that.